is the function f given by f of x equals a rational expression whenever x is not equal to 4. But when x is equal to 4, they say, oh, the function value is 7. So let's try to do this without looking at a graph. So using the definition of continuity, number 1, what do we have to check? Is f of x defined at x equals 4? If it is, what is f of 4? Well, the function says when x is 4, use 7, right? They said it right here. When x is 4, the function value is going to be 7. So yes, it is definitely defined at x equals 4 and f of 4 is equal to 7. So I'm going to circle that. I'm going to box this because this is what I'm going to compare the answer from the second part. Okay. All right. So we got the function value at x equals 4. Let's find the limit as f of x, the x approaches 4 of this function. So limit number 2. Does limit as x approaches 4 of f of x exist? In order to answer that question, we will compare the left-hand limit and the right-hand limit. But you know what? Take a look. To the left of 4, we're using this rational expression, this function right here. To the right side of 4, we're using this rational expression. Because what's happening is only at x equals 4, we're going to use the bottom piece. Whenever x is not equal to 4, which means like to the left side of 4 or to the right side of 4, we're going to be using this piece right there. So we can find, I thought about finding the left-hand limit and the right-hand limit and compare it. But we can go ahead and find what this is by finding the limit as x approaches 4 of this expression. Let me copy this right here. I'll just copy this. Copy. Oopsies. Paste image. Yep. I'm going to find that. What will happen if I plug in 4 directly into this expression? I'm going to get 4 squared minus 16 over 4 minus 4, right? Well, that's 16 minus 16 over 0. That's 0 over 0. That's on the indeterminate. We're not going to be able to find the limit by doing a direct substitution. So what do? We're going to have to factor and simplify. So take a look. I'm going to factor the numerator. X squared minus 16. We can factor that into x plus 4 and x minus 4. Well, there's that x minus 4 in the bottom of the fraction that we can cancel out now. So we're going to cross out the x minus 4. And now evaluate the limit of x approaching 4 for x plus 4, which is just going to be 4 plus 4 and 8. So the limit is 8. I'm going to conclude that down here, okay? Limit as x approaches 4 of f of x is equal to 8. So this is the answer from part 2. What I hope is that they are the same. Let's compare them. Oh, look at that. The first gray box right here, okay? All right, hold on. Let me use a different color pen. Blue. That's 7. F of 4 is 7. But the limit as x approaches 4 of this function is 8. They are not the same. So here's the conclusion, okay? F is not continuous at x equals 4 because they're not the same. F of 4 is not equal to limit as x approaches 4 of f of x. Okay? So, on your exam, show me these 3 parts. Find me the function value first. Find me the limit as x approaches that given x value, the function approaches that given x value, and compare them. If they are the same, you get to say, yes, it is continuous at that point. If they are not the same, like in this case, I got 7 and 8, they're not the same number, conclude and say that this function is not continuous at x equals 4 and state that reason, okay?